Hey all, welcome back to my channel. Itsuchi here, and I've got some exciting updates to show you guys. I wouldn't say I didn't get it done, but I mentioned in the last video that I may have that I was wanting that maybe part 3 would be about getting the first like GameCube or Wii animation in for like team specials. Haven't gotten there yet. There were many more pressing issues that I needed to get done before I suddenly jumped into that. Yeah, just wanted to set that preface. This video is not about that specifically. We're also going to be looking at our test animation that we did in the last two, that we discussed in the last two videos. But there's some cool things to talk about within that and other stuff I've been doing to get the cinematics down. So I will go ahead and jump in and show you guys what the current version of this ultimate jutsu looks like. Secret technique. Okay. Actually, I should update that. This is actually version like 3.5, I think. What day? Yeah, no, this is like 3.3. Forgot to update that. I'll just do that really quickly so you guys can see what this is like. Version 3.3. That's just so it displays on the title screen, and I also need to do it in my project settings behind my webcam. All right. Yeah, we're on 3.3. Yeah. All right. So now that our version is updated, now let's jump in. Okay, we're just going to practice as usual. Alright, I'll just get Naruto and Sasuke because I've been playing as them lately. I'm just going to try to keep things consistent. I'll try to showcase these jutsu as consistently as possible on the same stage so you can kind of see the progression of updates a little bit more easily. Okay, here we are. We are in our practice match. Here's the most current version of the cinematic. Alright, so I did make a tweak to the ending, not necessarily for cinematic purposes, more so for testing. You may notice that instead of it showing Naruto's face, it showed his backside. That's because I wanted to test out, if you notice here, I haven't moved yet. He is standing in that direction, facing the direction he ended in his pose. I wanted to make sure that was working. So when they end up, when the cinematic ends, I wanted to make sure that not only are the positions tracked, but also their rotations. So if I do need them to be facing a certain direction when they get up, I need to make sure that the rotations are getting tracked through the animation as well. So I just tilted his animation about a little over most of the way backwards. First, to make sure that he would retain his position, his rotation, which he did, and two, to make sure that the controls maintain as well, because he's facing slightly backwards. So if I were to walk backwards, it should orientate him facing that direction, and it does. Instead of glitching and causing him to, because there's a lot of checks for that don't happen during the cinematic. So I want to make sure when you return to the main game that not only is your rotation tracked, but all the checks happen to make sure left and right does what left and right is supposed to do, and it does. So it works flawlessly. Yeah, so that's really the only reason why I rotated him, was just to make sure that the rotation was working. Another thing you may have noticed is the background elements no longer clip, at least not in a noticeable fashion in terms of the flickering in the background elements. You would have noticed that probably a little bit more in the previous versions, because that was absolutely happening. I redid the camera logic, I wouldn't say completely, but I redid the camera logic quite a bit. I tweaked it quite a lot to do this. So basically what I've done is I probably will go too into it. I need to stop giving these disclaimers because I just be out here lying. So the way camera works is the camera physical tracking, like the base of the camera is actually tracking the direct center between the two characters. Specifically the two characters that are furthest apart on the stage. So if there were to be Royale, for example, then it would of course track. It will change that position based on who's the furthest away. So anyway, in two players, it's always going to be just whoever the primary characters are. So the camera sits right in between of those two. If I rotate, the camera's physical position for the base setup stays in the exact middle of these two characters. Then I have a couple of offsets programmed in there. So there's some tracking based on how close or far the two characters are apart. Will determine how close the camera is. When you're here, it's just kind of a fixed distance, but once you reach a certain distance away, the camera starts to zoom backwards, so there's some logic for that. And then even further is once you get to a certain distance after that, it starts to rotate upwards at about, I think it's doing it now, let me get some more distance. So Yeah, so if you look here, it's pretty much just zooming outwards, and then after a certain point, it'll start to rotate above and kind of look more downwards on the characters. So yeah, and this mimics exactly how it works in the Wii games. I don't think the GameCube games were exactly this. They were very close. They may be the same. I don't remember. I didn't track the GameCube's cameras. I based this off of the Wii camera. So this is a program based off of Wii camera logic. So anyway, that's how it works. So basically what was happening is in the middle of a cinematic, I actually just lock player 1 and player 2's positions at the center of the stage, as well as the originally the camera. So what was happening is on that last cinematic, if you notice, so since I'll just show you. All right, I'm gonna pause here. So right here. So basically in this exact moment, the camera still thinks the players are just locked to the middle of the stage because I'm just manipulating the models themselves, not the whole character. So the camera's not actually tracking the model, it's tracking behind the scenes invisible stuff. So the camera has no idea Naruto's actually over here in the original version. And then when I did pan the camera here, the actual physical camera is still somewhere else. So what was happening is when I get an angle this close, it's so hard to explain, guys, the setup. Here, maybe I can show you. Actually, I'm in the editor, so I can actually show you these things. It's hard to... I promise you this all has a meaning and a purpose for what was happening with the background objects. I just thought it would be fun for you guys to know. It's kind of the point of these vlogs, to see behind-the-scenes stuff in game design. So here's my camera. It's just locked to the center as a base core object. There we go. And it will never move no matter what's going on with the game. Excuse me. Then we have the actual camera details. This is the script that just controls all the math and stuff like that. This is actually tied to the characters, the actual camera. It's tied to the characters. So while the overall game object is just locked to the center of the stage, this actual camera is tracking the physical middle ground, like I mentioned earlier, between the two characters. That's why it's slightly off to the center here. I'll zoom in so you guys can see that. So just center overall, and then the actual camera tracking is in the exact middle. But that's not the physical camera. There's through lots of math, because again, I want to remember all those angles, doing different things like zooming in and out, rotating up and down. This requires parented layers to mimic these movements. So that's why there's so many parent and child objects doing different things like controlling the position, the rotation. All of these are slightly different. And then finally we get, oh yeah, it's not physically in here. And so finally, normally, let me exit the cinematic because the camera changes when you're in the cinematic. I forgot about that. All right. Okay, so after here we get here, now we have the actual physical camera, technically, which is here. This is that zoom and rotation out. Like I mentioned, all the actual physical manipulations of the camera in game to get the angle that we're doing. So that's actually here. That's a little bit obviously not in the center, because if it was in the center, you wouldn't be able to see the characters. So it's going to be a little bit further back so you can actually see the characters. And then underneath that, we have the actual physical cameras, which are even further back. This is because all this math is just getting the, all these other objects in the parent are just getting the general overall setting of where we want the camera angles to be. And then the physical cameras obviously are what paint the image. So if I want to tweak camera angles, make it, change the depth anywhere in gameplay, I want to be able to do that freely without having to modify code. So that's why the actual cameras are different from the apparent objects. So yeah, the cameras sit at this kind of offset. They're about -5 away, +1 on the y-axis, and they're at a tilt of -3.5 on the x-axis, which gives us this final presentation. I can show you what some of these variables do. So this is me warping the character camera. That's what that angle's controlling. The +1 controls that. And then depth. So that's kind of how these variables work. So if I ever want to change the actual positioning of the camera on stage, I would never touch the coding. I would just come in here and I would tweak these variables. Also depth, where's the depth of field of view? That also warps things like this. So I would change these variables so I don't have to deal with programming. It's just quick setup. So anyway, that's why these all don't match. I say all of that to say that what happens is when you do that pan in, if you notice, this is the actual camera that I'm treating as the physical camera, if you notice, that's much closer to the characters than the actual physical rendering camera. So that means if I want the camera to zoom in on someone, in order to make that effect happen, let's say I were to move it like this. Oh, that's actually, I should do the character camera instead. All right, if I were to do it like this, move this camera close to the character to get that zoom in, that's how close the physical camera needs to be. But since the physical camera object is so much closer, to get that same effect, I'd have to do it like this. And you see now this object is so much further, excuse me, than the actual physical camera that's rendering. Because of that, the way the logic works for background objects is it tracks, is the physical camera closer to the background object than the two characters? If so, then clearly the camera, we need to turn off these objects. So in this case, these background objects are turned off because the physical camera is closer to them than these two characters. There's never going to be a situation where the physical camera should be closer to a background object than the players, because if that were the case, then it would be like this. I'm sorry, if that were the case, then the characters wouldn't be visible. Because so that's how the logic works. So because of that, what was happening is in that final moment, when I zoom in on the player, the physical camera, the actual rendering cameras to zoom in, cause the physical camera to actually be slightly past the main player. And because of that logic, that means that it would turn off the background elements. So I addressed this through two things. First, I did was, instead of tracking the physical camera location, I tracked some distance between the main camera, the rendering camera, and the physical camera location. That helps better give me just enough barrier. I'm sorry, not that. That. So yeah, and that gives you just enough of a buffer for those minor overlap to not have to cause a problem. And I also changed it so that when I am tracking the camera in a cinematic, instead of tracking the invisible objects, like say that control the characters, it's going to track the physical models instead. That's not good to do in-game because then the camera starts shaking unnecessarily with the animations of characters. So that's why I don't track it during mid-game, but it's fine to track during a cinematic when the camera's being manipulated. So anyway, I hope any bit of that makes sense. I did all of that work so that when it overlaps in a cutscene, the background objects, the camera will still be considered as closer to the background objects than the characters, and it won't turn off some of those other objects. So that's why the objects start turning off. Phew! That was a mouthful. So now let's talk about some more exciting things that are somewhat related. You may have noticed after the cinematic ends, there's a much smoother transition from this camera to the actual gameplay. It actually, when it's moving that quickly, it's almost even hard to tell that there's even there's actually only one frame of overlap. Let me see if I can catch it for you. All right, we'll pause and then we'll just play this back frame by frame. There. So that's like the only off frame that would be, where the game is kind of doing that cross from switching back from cinematic to then repositioning everything to track as if it was in game. And there's one frame during the transition where it does draw a frame of that in-between section before snapping back to how it's supposed to look and then panning from there. So literally one frame. So you'd have to really play it in slow motion to see it. And this happens in the original Clash Ninja games as well. There's no difference between my game and those games. They may add a transition like a blur over the screen or a flash to help hide it. Like some specials may flash white really quickly and then fade back out as the camera zooms in to help hide that transition period, or it may do like a blending of frames, which I might do too. I might add a blending of frames where it'll kind of merge frames over. So while it still does draw it only draws it half of it and then it skips over. So it helps by blending the frames together. It helps smear and blur that transition period. But like I said, it's so fast. It's exactly one frame. In the drawing process, that at 60 frames per second, you probably wouldn't even, you're not really seeing that. So I don't really have to do anything, and it would still look just like it does in the original games. So yeah, that just cleaned up that whole transition. And then and I also cleaned up the code in a way so where this is all much smoother with animation. I had to do a lot of background stuff in the animation itself for the cutscene, like disabling collision for the players. I decided to get rid of all of that out of the animation, add all of that to code, putting the characters in a special cinematic, status. So that way all the collision and all that stuff is handled through code. Every time the player enters a cinematic, so on the animation side, all I have to do is the physical visual animations. I don't have to do any special kind of collision stuff like I did in the last version of this animation. It's all cleaned up now, so I just make the animation and put it in the game and it works. This will make it much easier when I do decide to import those Wii and GameCube animations. I can just add the animation and it will run in the game. And that's about it. And the cutscene will automatically, the code will handle all the smoothing out, all of that will be handled solely by code. The importance of this is every animation I'll have to add manually, but by putting as much stuff in code as possible, I only have to code it one time. And once it's coded, it applies to any future animations I add. That's the benefit of the change that I made. Again, it's not something that you'll see in gameplay, but it's something that'll smooth out the development process over time by adding in all those extra tags of, remembering to disable collision when you start the cinematic for every player. I don't have to do that anymore. That's all handled through code. I just make the character move, and the code will handle making sure all the collision stuff is handled. Alright, the final thing I want to talk about is probably the most significant change. I already teased my Discord, and it's technically, you've already seen it in half action, I just didn't point it out yet. When I use this special, you may have noticed the background is slightly different. It's from a different angle than it was in the previous version. If you remember when I do this attack at this moment, Sakura should be flying towards the Hokage monument, but she's not. She's flying to the side. Same thing with this. That shot should be facing the opposite direction, but now it's not. The reason that is because I added in this. If I were to come on this side of Sakura and use the same exact special, the angle has now changed again, and now she's back in front of the Hokage monument, but it's not centered. What I added was rotation to the jutsu. So cinematic jutsu in the original games were always executed on a fixed rotation. Exactly as the developer animated it is exactly how it plays 100% of the time. This could lead to some drawing actions. For example, if I were to use Naruto's special originally, even if I was facing the Hokage monument and I was very visibly facing on this side of Sakura, if I was to use the jutsu in the previous version, I would just somehow teleport to being on this side of the stage and she's on that side of the stage. Which, again, with cutscenes, that stuff's usually irrelevant, but to make it a little bit more seamless and to shake things up a bit, since I'm not as good on the visuals, to at least add some consistency to the not as flashy as Storm cinematics, I applied rotation. So what happens is it will be able to figure out Naruto's orientation when he throws jutsu, and then it'll orientate the jutsu based on that. Now his position does still change. I could add in position warping. The reason why and the position warping was in the original GameCube games for some of the simpler attacks like Sakura's barrage and Lion's barrage. Since those are a little bit more simpler, more vertical than like they stay mostly in place, they actually allow those to actually be positioned. They take place on rotation and position. So the GameCube games did have that for some of this, because a lot of the cinematics in that game were simplistic. In the Revolution games, in the Wii games, that's where jutsu started to get more over the top and the cinematics started to get better. So they just made everything fixed to a fixed position and rotation. This is because stages vary in size. So if in this attack, for example, when you hit them, they go flying back, and you need to be able to simulate that in space. Because of that, that's why it's good to lock them to the middle, because another smaller stage may not have the same space available as this one. So because of that, I still lock the position to the middle, but I will use the equal amount of space for all. Since I use the equal amount of space for all directions, it doesn't matter what rotation they're doing, as long as it's physically. All stages are based from the center, so as long as the distance between the center of the stage and the outer of the jutsu are within every single stage's boundaries, then it'll be fine regardless of rotation. So rotation is okay, but not position. It's about halfway like the GameCube games. More robust than the Wii games, and almost as good as those use cases in the GameCube games. But yeah, so it doesn't matter what rotation you're facing, the cinematic will always play from that perspective. I might add, because if you notice, like, if I hit him from the side, the camera does treat it as if he was hit if the Naruto was on the left. But if I attack her from the right side, it's even though the rotation is still matching, the camera angle switches perspective from Naruto being on the left to him, from Naruto being on the right to him being on the left as the default. So I'm toying with the idea. It's a lot more work of having a player 2 and a player 1 perspective, meaning if I were to hit from the left, it'll play the cutscene like this, as him attacking from a left to forward, left to right. And then if I attack from the right, this would play a special right side version that would then warp the camera. It will be all camera animation, just be a secondary camera animation. But I'm reluctant to do this because it would be so much work doing 2 camera manipulations for a jutsu. And some jutsu may not even be worth it. Like if the jutsu starts off with the camera angle being forward facing, then it wouldn't even matter. It just so happens that this jutsu starts from a left to right perspective than a direct head-on perspective. So it wouldn't even be applicable to a lot of jutsus that start off from a direct standpoint. So I'm reluctant to do it, but it is on the table. If you guys think that's this big deal that's worth adding into the game, then it is possible. It just means every animation will require 2 versions, a player 1 and a player 2 version to differentiate left and right, and it would just be camera manipulations. GNT4 actually did this slightly. I don't think it was necessarily tied to player 1 and player 2 like which side showing, but there are actual multiple versions, at least 2 versions of the same jutsu for some of the characters, not all. Examples of this are Naruto's Uzumaki Barrage and Sasuke's Lion's Barrage, I believe, has 2 versions. They take away the same damage, same all of that, but the camera angle is different for them. Same jutsu, same setup, just different camera angles depending on perspective. An example is Naruto's Shadow Clone Jutsu. You may see it when you use it. He may have a forward camera where it just shows all the 5 clones up front. And then there's an alternate version where it actually doesn't show all of them in one shot, but rather it starts on the focus on the right side clones and then pans itself across to the left, kind of revealing them in this dynamic way for the 5 clones as they appear. So GNT4 does have multiple camera animations for some of those jutsu that they use. So it wouldn't be a foreign concept for me to do that. It's just with scale, the amount of cinematics are going to be in this game, even the increased amount per character. Many more characters are going to have multiple cinematics. Like, for example, because of extra transformations is what I mean. Like, Naruto's going to have so many more transformations within one character, so many more, and that's going to be more cinematics. And then every cinematic would need to have 2 versions if it's not a front facing. So again, it's an idea I'm toying with. If you guys think it is definitely worth the effort, drop a comment, let me know. I mean, I'll definitely consider that. I definitely need to know early on, so I can set in the that I would have to program logic to determine which side you're on and which animation to play early on. So please let me know early on if that's something you guys really think is worth the extra effort. Otherwise, yeah, and I'll consider it. So yeah, that is the last big thing I want to talk about is the camera rotation for these jutsu. Yeah, and it's working. Unrelated, a glitch I had to fix was pausing. In the prior versions, I didn't even notice, but you didn't have the ability to pause during a cinematic due to the code and the way it's structured. So yeah, but I fixed that last night. It took me a long time. I think it was like 4 a.m. and I fixed it. So yeah, I got the pause menu to work no matter if you're in a cutscene or not. It's not perfect because I also realized the pausing is controlled by player 1's code. So that means if let's say I'm in Royale and player 2 hits player 3, for example, that would disable player 1's game object, so that they're not blocking the screen during the cinematic, which means player 1 would lose the ability to pause the game during that cutscene. And that might be jarring to where you can pause during your own cutscenes or any cutscenes you're involved in, but you wouldn't be able to pause during unrelated characters' cutscenes. That would be weird. I accidentally took a screenshot. I will probably have to add in a code. What I can do is I can probably move the pausing mechanism up a level to the parent object, so that way pausing would be controlled by the game's code, not the individual player's code. I did this because obviously I only want player 1 to be able to control things like pausing, but I can still do that. I can basically share controls are actually variables. Like player 1's controls are actually physically in the code player 1's controls. So what I can do is just when player 1 is spawned in, I can just share, hey, by the way, parent game object, here's player one's controls. So if player one's controller hits start, regardless of if they're active, just note that you need to pause. That's player one. So I can share player one's specific buttons as variables upwards. So I'll just have to migrate again the pausing code upwards, which includes the logic. That's the main problem. Is the logic. The logic currently is tied to player one, so I just have to make sure I can successfully move that logic upwards. It will be for anything that's admin related, like resetting a practice match, pausing, all of those kind of player one admin stuff need to be moved out of player one, out of the characters code and moved up into the overall game code. And yeah, that's just, yeah, there's a lot of variables and lots of sharing of data between the whole game, and that's delicate. So I'm like, I'm not particularly keen on doing that. It's simple enough. It shouldn't be too hard, but it's just, the thing is, moving all the stuff up will work, and then you find out later you broke something in the game's code, and you got to figure out what you broke, what did you move, what's not working, and that's just the process I don't like. But anyway, with all that said, I did get pausing working, at least during cinematics that player one is directly involved in. Like I say, I already am aware of when I do turn off background objects for unrelated characters, that player one I'll need to remove admin commands, like pausing and resetting upwards to the parent object, which stays active. And then the final thing I did note that's still not working, it's better but it's not working, is I'll pause and show you guys behind the scenes. In order to get the rotation to work, I had to create a parent object in real time and move all the characters in camera, in anything that's bound to the animation, I have to move into that new parent, and that's what this is, the cinematic jutsu general object, and this is where I can have it rotate any direction I want. So this is what's controlling that animation to have them do it. So that's how I got it to work. And since I migrated all these objects into here, I also decided to bring any suspended game objects. This would be background characters. There are none in this since it's one-on-one, but the parent objects still exist in time. So even though there's no P1B spawned, that's player one's teammates, and P2's two teammates, their parent objects stay in there, but there's just no characters tied to them, so they're stay null. But in principle, since they exist still in the game, they are moved into the suspended object, because them and anything else in created, like let's say there's kunai that were created. I can actually show you this because we're in the editor. I'm sorry guys, I'm not used to like having vlogs on the editor where I can actually show you the stuff. So like let's say I were to throw some kunai and then use a jutsu. So those kunai exist in, this is also a glitch, these random game objects keep getting created, and I need to figure out what's creating them. They get created every time I execute a jutsu. Anyway, so those kunai are now in here, inside the suspended games, because if you throw a ninja tool in let's say in Royale, and then someone uses a jutsu, after that jutsu ends, you want that ninja tool to still be exactly where it was and continue on from where it left off. So that's why they're in here, where their movement has been suspended. They should be down. Oh, that's the parent. They're down here. So sorry, the game's glitching. All right, here we go. Oh yeah, they're off. So that's why I'm trying to see them. Like I'll show you, but yeah. So that's physically where it is. It's down in the ground traveling. Obviously, this is just one I threw down into the ground, and just to show you that it's still in the game. But it's been paused. Its movement's been completely paused. And then when the game resumes, then it will resume. Like after the cinematic is when it will resume its progression. The only issue that I have so far is these are on a timer to destroy themselves after a fixed time. Normally, I'll have to program later so that they get yeeted on collision with the stage. But for now, they just travel indefinitely until they hit a player. So these are traveling indefinitely, but normally when they're traveling indefinitely, they'll expire on a timer. The issue is that I found is you can destroy a game object on a timer through a code, meaning I could say destroy this kunai after 10 seconds. And it will just do that after 10 seconds, which it's not that long, it's like 3 seconds, but, or 5 seconds. And after those 5 seconds have passed, it will automatically destroy the game object. I don't have to check back after, I don't have to count, wait 5 seconds and then kill it. I can just do it all in one code. Spawn it, and then just destroy yourself in 5 seconds, and it'll do that. The problem is, even when a game object is disabled, that specific way of killing the game object maintains itself. So even though these objects are not moving and their whole code's been suspended, since it still has in its thing to kill itself after those 5 seconds, the game is still running, it's going to kill itself after those 5 seconds. Obviously pausing doesn't count, but as long as the game is still running, even if they're disabled, that timer is still going for that. So because of this, that means I will have to not use that way of getting rid of projectiles and anything else that uses that, such as effects or anything of that nature. I'll have to recode. Not particularly looking forward to that, but that would be a next step before I move on, because again, I need to make sure this is working so that I can adequately suspend game objects during like Royale and things like that, so they pick up exactly where they left off with their timers. Actual coded timers, where I can actually set up an in-game timer and then have it count down through code and then execute the destroy after that time ends. That will work because that timer would get disabled when the game object gets disabled. It would not count. In theory, I'll have to check, but in theory, that timer should not count. So all I'll really have to do is just change that code for all the projectiles that are in the game's part, which is the annoying part because I have different code for Senbon, different code for Kunai, different code for Shuriken because their properties are different. So I'll just have to make sure I get every single one that uses this version to ensure that it's not getting destroyed on its while it's inactive, because that will obviously that's not conducive to good game design. If you throw a kunai and then suddenly and you're penalized for it, obviously you're stuck in the recovery frames, but your kunai disappeared. They disappeared during someone else's cinematic. That wouldn't be fair, and now you're just left vulnerable with no. That's not fair. So I need to make sure that this stuff is working for consistent gameplay. I think that's it. Yeah, that should be everything I want to talk about. I'll work on that stuff and get all that ready for the next video. But in terms of the actual core one-on-one cutscene, it's pretty much flawless. Yeah, pretty much flawless, and it works with rotation. Yeah. Alright. Thanks for watching, guys. Cheers. And have a nice day / morning / night, whatever time you're watching the video.